encryption, challenge data privacy, and create new opportunities for cyber defense. Understanding this shift is crucial for anyone interested in technology, security, and the future of digital trust. To guide us through this important subject, we are honored to have with us an esteemed expert. It is my great privilege to introduce our speaker, Mr. Vivek Menon, Senior Corporate Trainer at Corning Solution. Welcome, sir.
Thank you, Aishwarya, for the welcome.
Apart from corporate trainer, he is a certified data protection officer, certified ethical hacker, and PCI DSS expert. He also brings valuable real-world experience as a former cybercrime investigator, having assisted the Kerala police. Now I request Mr. Vivek to kindly take over the session.
Sure. Give me a second. Let me turn on my camera. Hello, Aishwarya. Am I visible? Am I audible? Aishwarya, are you able to hear me? Hello, Aishwarya.
Sir.
Yes. Are you able to hear me?
Hello, sir.
Yeah. Are you able to hear me?
Sir.
Yes.
Yes, sir. You are audible.
Okay, cool. So I'll just share my screen first just to test whether the screen is working clearly. So are you able to see the screen? Yes, cool. So good evening, everyone, and I hope everyone is from India. So I'm from India, so I'm saying good evening to all. And those who are from other part of the world, hello, everyone. Welcome to the session. We will be discussing about quantum computing and the future of cybersecurity. And I hope the people who are here will be interested in technology, even though we will not be discussing or we will not be deep delving into what quantum computer is or the extensive working structure of the quantum computer. We will be discussing or browsing through the areas of concerns related with quantum computer and how the cybersecurity can be improved and what will be the future of cybersecurity by using the quantum computer in the organization or the upcoming future of quantum computer. So let me introduce myself first. My name is Vivek M. Menon, as Aishwarya has described. So that is a brief introduction about myself. I'm from India, I'm from Kerala, and working currently as a senior corporate trainer in Koenig Solution. So today we will be just going through the technology, which is quantum computer. I hope everyone should be ready for the presentation so that we can start with it. And if at all you have any kind of concerns, if you are having any kind of doubts, please do put it in the chat box. We will discuss the chat at last. We'll discuss about any kind of issues at the last. And yes, I hope we can continue with the session. Okay. So a little thumbs up here and there will be helpful. If at all you are able to unmute yourself and speak, that will also be appreciated. Yeah. So quantum computer. I will give you a brief idea about quantum computer is. Quantum computer is nothing but it is a new kind of technology. So we have computers in the past. We have computers, the modern computers that we use. We have supercomputers that are available readily everywhere right now in these days right now. So quantum computer, how quantum computer is? It is not an advanced supercomputer. It is no way related to supercomputer. Instead, consider that we had a car which would take us to some extent from A point A to point B. It would take us, a car will help us to move from one A point A to point B. Now consider about a boat. Now boat is not an advanced version of car. Boat is used for a different kind of transportation, isn't it? So likewise, quantum computer is not a super or advanced computer. It is a different type of computing purposes, which will help us to move from point A to point B in a different way or in a different type or different areas to cover. So that is what a quantum computer is. And that's just a brief idea about quantum computer. First, we will discuss about the agenda that we are having for the day. We'll discuss what a quantum computer is in detail. We'll discuss about the technological term, the jargons. To break down the jargons, we will describe what quantum computer is and what are the terms associated with it, how the quantum computer is working. This is the first part that we'll discuss. Moving on to classical cryptography. So we are also talking about quantum cryptography here. We'll talk about quantum computer. We'll talk the applications of quantum computer. In the applications of quantum computer, the one of the major term that we use is quantum cryptography. It is it is one of the most feared area that is there while developing the quantum computer, and how this quantum cryptography will be affecting us even now, even when the quantum computers are not a commercial product nowadays. Clear? Moving on to third product, which is quantum threats to cybersecurity. Now, quantum threats to cybersecurity, we'll again discuss about quantum cryptography over there. How quantum computers can affect the security about the people who are using data like me, like you. Shor's algorithm and Grover's algorithm, post-quantum cryptography. That is, if quantum has been released widely in the around the world, what will be the use cases of that and how we can make sure that we are secure from that. We also discuss about quantum key distribution. That is again a technical area that we'll be discussing in the upcoming sessions. Industry readiness and compliance, how we can be secure, how our organizations can be secure. That will be discussed under industry readiness and compliance. Migration strategies and future outlook, how can we be secure in future when the quantum computers are commercially available. And finally, Q&A. You can ask all your doubts in the Q&A. We will be discussing each and everything clearly and in a perfect way. We'll discuss, and only then I will leave the meeting. So I hope everyone is ready. Again, a thumbs up would be great if you could. Yeah, great. Everyone is ready. That is fine. So moving on to the term quantum computing. So now quantum computing, as I said, it is a different method of transportation. Like a different method of it's a method of transportation. For example, let me say, consider that there is a password which I've created. So everyone has been tired of hearing what a password to make sure that a password security. That is, you should use the capital letters, you should use the small letters, you should use special characters, you should use the numerals, right? So now consider that there is a particular computer. So how password, like why we say that the password should be long, the password should be having multiple characters? The reason is there is a type of attack that is very much used even now, is called as brute force attack. Now this brute force attack, what happens in brute force attack is the attack will be initiated by trying out each and every password. For example, let me say 0000 is the password. Consider that the password is 0000, which has a 4 characters. Now what I'm trying to do is, there are 4 characters. I know that the password has 4 characters. Now what I'm trying to do is, I will try all the possible permutations and combinations of 4 digits. So I have the number from 0 to 9. I will try each and every permutations and combinations of those 4 4 digits with all the 0 to 9 numbers. Now at one point I will be able to crack the password. I don't know whether while I initiate the command or I initiate the attack, I will be able to find it out. Maybe after 1 hour I'll be able to find it out. Maybe after 10 hours I'll be able to find it out. But we can find it out, isn't it? So consider that. So that is the reason why everyone has been saying that you should use a huge number of password. Like the character should be long. There should be different types of characters used in that particular password. Now, so that the time taken will be much more. Right. So again, encryption or the security that you use is not making the system secure, but it is making the person who is trying to attack the system much more harder, or it is giving a hard process for the person who is attacking the system. Again, we are not making the system secure. We are making sure that the other person will be, we are making sure that the person who is attacking, it will be hard for the person to attack. So that is what encryption is. Now, for example, when we are using a 50 rupees lock on a door where the material used in the lock is cheap, it will be easy for the person to break the lock. When we are using a 1,000 rupees lock, it will be making that person much more harder to break it, because the material will be titanium or any other strong materials. It will be much more secure. The number lock will be there. So such kind of advancements will be there, which will be, again, a lock is not making the person impossible to get into or break the particular system or the particular door. It is making the person hard enough. So if a person would have tried at once, will be trying 100 times in order to break the lock. Similarly, it happens in encryption as well. Now, quantum computer, talking about quantum computer, looking forward to a traditional computer. Let's say we'll discuss about traditional computers first. So you know that there is something called as bits in traditional computer, which is the smallest point of communication with the system, that is zeros and ones. That is the language of computer. Everyone knows that. Zeros and ones, that is bits. Now, in this bits, so a bit will be put in a table saying that okay, there will be 4 points. Consider that I'm taking 4 bits. So here it will be 0, here it will be 1, here it will be 0 again, and it will be 1. So let's say this is a bit. Now we know that this column will be 0 or 1. Again, this column will be 1 or 0. There is no possibility that it can be seen. Now, when it comes to quantum computers, we have the 0. So this particular column, we cannot say that whether it is 0 or 1 until or unless we observe it. That is what we call it as qubits. Now, qubits are something which is similar to bits, but in quantum computer, we use qubits instead of bits. Quantum bits, that is what qubits means. Now, qubits is a particular area or the particular bit which has a possibility of being 0 and 1 at the same time. Now, how it is possible? It is possible via this particular term that we have seen, that we are seeing here, which is entanglement. We'll come to that before we will discuss about superposition as well. Now, superposition, again, when you hear the term quantum, you know that it is a physics. It is related to physics. We are talking about physics over here. Quantum mechanics, it is a physics subject. The study of areas or materials which is lesser or which is having lesser size than an atom. We're talking about protons, we are talking about electrons over here, how the working of electrons is. Similarly, in quantum computer, we are talking about electrons. That is how an electron will be having the capability in order to carry particular data, which is 0 or 1. Now, superposition, consider that you have, the best example to take is the light. Maybe it is dark. Whoever is in India, it will be dark. It is in night time, so it will be dark around you. Consider that you turned on a light. Now, what the light is? Either the light is a ray or a wave. But according to physics or according to quantum physics, light is a wave and a ray at the same time. That is what a superposition is. An electron will be ray and wave at the same time. A superposition. Depending upon what we observe, it will change its position. It is also related with the Young's double modulus experiment. Those who have taken physics in the session, that you will be able to know what Young's double slit experiment is. No, I'm not going into that deep in physics. I'm just giving you an understanding that a photon or an electron will be ray and in wave structure at the same time. Now, coming back to entanglement. Now, entanglement was created, or those who have seen Big Bang Theory, which is a series available in Prime, I guess. In that, there is a particular episode which is talking about the Schrodinger's cat. No, the entanglement is related, again, founded by Erwin Schrödinger, which is a scientist in somewhere around Europe. The Erwin Schrödinger proposed a thought experiment saying that if he's putting a cat in a box and a half-life uranium and close the box, until or unless we open the box and observe the cat will be dead and alive at the same time. Similar to that, take an electron, the electron will, in an excited state of an electron will be split into two. Now, in that particular area, when we take these two electrons, these are having some quantum features or quantum. This will follow quantum principles. Now, in this quantum principle, there is something called a spin quantum associated with it. It will be either spinning in an upward direction or in a downward direction. Now, until or unless we observe this electron, this will be spinning in upward direction, or until or unless we observe this, it will be spinning in upward and downward direction at the same time. The moment that we observe the electron, it will choose a side. At the same time, the other electron, the negatively charged electron, the negatively charged particle of this, will be spinning in the opposite direction. Only then it will be equalized into 0. Now, it will be, at the moment that we observe it, it will choose a side. At the same time, the other electron, the opposite electron, will also choose the opposite side. Now, that is what an entanglement is. Now, how electron is knowing that, whether we are observing or not, we don't know. Scientists have not discovered that yet. How they are choosing, so how the other electron is getting to know which side the electron has been chosen, we don't know. How they are communicating between each other. Now we talk about, so that is quantum entanglement. Now again, when I say that we are not able to understand quantum mechanics completely, it means that there is no one in the world who can explain why this happened. Even the scientists even the physicists who are working in the area are not able to explain us why the entanglement happens or how the entanglement happens. Moving on to quantum interference. Now in quantum interference, we are talking about waves. So consider that you are putting two pebbles into a pond. The waves will be created in the pond. Now, in the waves, there will be an up wave and a down wave, right? Consider that when an up wave and a down wave is intersecting with each other, they will be canceling it out. Now, when the up wave and also the up wave is intersecting with each other, they will be enhancing into a much more bigger wave. That is the same criteria that is happening over here, which is called as quantum interference. That is, it is manipulating the waves in order to amplify the area, say amplify the signals or amplify the waves that is emitted from the electrons. Now, again, we are coming back to the point. Quantum computer will use all these principles. And the only thing that we need to know about this is, it is the quantum computers or the qubits will be using either 0 or 1. It will be having it is choosing zeros and 1 at the same time. It will not use a same, or it will not use zeros or 1. It is using 0 and 1 at the same time. Let me clear everything that I've written on the slide so that we can move on. Classical cryptography. I know that the image is breaking or image is not letting you see it, but I will explain it to you. Now, classical cryptography today. Now, classical cryptography today is, we are just discussing about cryptography. Before talking about cryptography, I need to talk about cryptology. Now, cryptology is a field of science which talks about the crypto, that is encrypting and decryption of something or information or a data. Now, cryptology is divided into two. One is cryptography, and also another one is called as cryptanalysis. Now, cryptography is talking about encrypting and decrypting the system to make sure that the system is secure, whereas cryptanalysis is talking about how we can break the cryptography. So two options, that is cryptography and cryptanalysis, where cryptography is talking about securing the system, and cryptanalysis is talking that how we can break the securing system, or how we can break the cryptography. Now, again, cryptography is divided into two. As you can see here, it is public key encryption or public key cryptography, or asymmetric encryption. We have symmetric encryption or private key encryption or private key cryptography. Then we have hashing. These are the three different areas. Now, public key cryptography is nothing but, for example, consider that there is before talking about public key, first thing that we need to discuss about is a private key or a symmetric encryption. Consider that there is two people who is Alice and Bob. Now, I don't know why every books all around the world is talking about Alice and Bob when it comes to cryptography. Again, it is how it is designed. Now, each of them will be having a key. That is, consider that rather than a key, what we can discuss is, consider that you have a lock and a key with you. The other person is also having a key. Okay, consider that you have a padlock and a key with you. The other person is also having a padlock and a key. Now, what you're doing is, you are using this lock in order to lock a particular box, and you give that to that person. You also give the key to the other person so that the other person can open and look it up. Now, when you are sharing a key through this open network, it is easy for another person, which is called as an eavesdropper or an Eve, to get into the system and make a copy of this key and use it himself to unlock the lock and see what it is there in the box, right? Now, how we can make sure that it's secure? Again, there are different other methods that it is used for securing this key transfer, which is one of them is Diffie-Hellman key exchange algorithm. Now, there are two algorithms for Diffie-Hellman. One is the Diffie-Hellman encryption, and then there are Diffie-Hellman key exchange algorithm, which we are talking about how the keys can be securely exchanged between one party and the other party. There are two different types of key exchange algorithm. One is normal Diffie-Hellman key exchange algorithm. The another one is called as elliptic curve Diffie-Hellman key exchange algorithm. Now that is what a public key encryption, sorry, private key encryption is. That is, we are only using a single key. That is the reason why we are calling it symmetric encryption. We are only using a single key, which will be shared with the other party. Now we are going back into the public key encryption. Now in public key cryptography, again, we are taking two different parties, which is Alice and Bob. Alice and Bob. Yeah. Instead of one key, these guys are having two keys with having features with these two keys. These guys are having public key and also private key. Now, public key will be shared with the other party because the public key has only option of public key's feature is only to unlock the lock. Sorry, again, public key has only will be only able to lock the particular or encrypt the particular message. The public key will only be able to encrypt the message. The private key is the one which will be able to unlock the message. Now, the private key will not be shared, will not be exposed, will not be given to any other person. It will be kept within themselves so that it will not be able to, any attacker will not be able to access those keys through the network. Now, even if the Eve come here in order for the stealing the information. So Eve is a thief. So he is coming to steal the particular information. Now, even when the data is shared and also the public key is shared, the Eve will only get the public key, which is only the ability to log the information. So even when the logged box is given to Eve, the Eve will not be able to unlock it because the public key that is there with the Eve will not be able to unlock the lock, but only to lock it. Now consider how the Bob will be able to open it. You might be having a doubt. Now what we do here is the Bob will share his lock or the key which is used for lock, which is called as public key, to the Alice, and Alice will share the key which is able to lock Alice's messages to the Bob. Now what I will do is, so I have Bob's, consider that I am Bob. Now Alice is sending me a message. Now what the keys are, what are the keys that I'm having? I'm having the public key of mine, I'm having the private key of mine, and I'm also having the public key of Alice. Now when Alice is sending me a message or Alice is giving me a message, what Alice do is, so or else let me talk from my side, that I am Bob and I'm sending message to Alice. Now when I'm sending message to Alice, what I'm doing is I will lock the message with Alice's public key so that the Alice can open that particular lock with her private key. So I will lock the message with the public key of Alice and I will send the message to Alice. So the Alice is having a private key which she has not shared with anyone, that she can use in order to unlock the message and see the message. That's how the public key encryption works, and which is considered to be much more secure. Now there is something called as hashing. Now hashing is not at all part of this. Hashing is a separate area or separate topic which we will be discussing about just to encrypt it. So hashing is a one-way encryption. Once you hash a particular message, you will not be able to revert that particular process. You will not be able to take back that particular process. Hashing has the only ability to log the message. That is, while encrypting. So again, some algorithms are used. One is SHA-3, one SHA-256 are used. Now, when we are encrypting the message, we also add, other than from the algorithm, we also add some kind of something called a salt. So salt is a random key generated by the system. We don't know what the salt is. Only the system knows what the salt is. Again, if an attacker comes into the system, the attacker will not be able to find what the salt is. Now, that is how secure the salt is. Now, this is how the passwords are saved in the databases that we keep. For example, in Facebook database, you cannot find your password however it is typed. For example, I'm saying that my password is Vivek Menon. You cannot find my password as Vivek Menon, saved as Vivek Menon in the password database of the Facebook. It will be present as a long random string. I don't know what it is. Even if someone attacks, they will be stumbled upon that particular word saying that, oh, what the hell it is, right? So these are the few encryption technology that we are still using. Now these are using numbers. Max is one of the major important topic that we need to understand when we are talking about cryptography. We are having few of the algorithms, which is RSA, ECC, and Diffie-Hellman. We are having AES and Cha-Cha-2. We are having SHA-256 and SHA-3 as an algorithm for hashing. So these are the few topics associated with hashing. I hope that is clear with you. If at all you are having any doubt, you can just type it in the chat box. We will be able to discuss it much more. Now, talking about quantum cryptography or quantum security in the threats that are associated with the quantum computers. Now, consider that we have talked about this encryption. So it is using huge numbers. So it is using the largest prime numbers, which are having 20 characters. Consider that the AES is an algorithm which is used, advanced encryption system. So this particular system is using 40 digits. So the largest prime number, which are having 40 digits, and it is multiplied with another 40 digits to make sure that the particular messages or the encryption method will be secure. So this is how it works. Now they will repeat this process in order to make sure that the system is secure at most. Now consider that a computer, a normal computer, the classic computer that we are using, whether it is a MacBook Pro or Ultra, whatever the computer that you're using, the most powerful system that you're using, the system will take at least 200 years, 2000 years in order to break this huge number, huge prime number. To factorize this, the system will take 200 years, 2000 years. There are passwords that which are created, or there are encryption systems that are created which will take 2 million years in order to break into this particular, or break the particular prime numbers, because it is guessing new numbers again and again and again. Because again, we told in a bit we can only include a single digit at a time. Only in a qubit we will be able to use 0 and 1 at the same time. So when I say this, it means that when we are using a quantum computer, for example, there are 10 digits that we need to try at once. The qubit or the quantum computer will be able to try that 10 digits or 10 numbers or 10 passwords at a single second. When the normal bits have to try one by one by one, the qubit can do it once, and we get to know what the answer of all these tries are. That is what a use of quantum computer is. That is what, again, we are talking about the modern modern encryption, which relies on integer factorization. That is integer factorization. We are talking about a huge number of 40 characters of prime numbers, and we are factorizing it again and again. Then we are using discrete algorithms like ECC. So it's some huge algorithm that is there, which is working to make sure that the system is secure. Now, what quantum computers do is, quantum computers are very easy. So there are two different algorithms that we'll be talking in upcoming session, which is Shor's algorithm or Grover algorithm. We'll see how they works while we are we're talking about integer factorization and also discrete algorithm. We'll see how they are interpreting, or how they are able to break the integer factorization and also discrete algorithm. Again, these are mathematically hard for classical computers, but not hard for quantum computers, because the quantum computers are having the ability to do or to try multiple qubits at the same time. Hope that is clear with you. We are looking into Shor's algorithm, as I said. Now, Shor's algorithm is very simple, that we are talking about the factorizing the largest integers. So what Shor's algorithm does, Shor's algorithm is very simple. When it is very simple to explain, but it is hard to understand how it works. Now, explanation is that when there is an encryption key, consider that the encryption key is a 40-digit long system, a 40-digit long characterized key that is we are using. In that, what Shor's algorithm does, Shor's algorithm is randomly guess a particular password or particular key, which will be wrong. Obviously, it will be wrong. Again, from this wrong input output that they got, so they say that is wrong, it will guess, and again it will guess, which will be closely related with that particular original key that we are talking about, and they will be able to easily guess what the password is. Here again, it is very easy to explain, but it is very hard to understand that Shor's algorithm will guess the password in 2 or 3 tries. Now again, when I'm saying guessing the password, we are talking about factorizing large integers. That is a 40-digit integers, or 40-digit integers we are talking about, factorizing it to a clear answer within a short period of time. So it will be the short algorithm is able to break RC, ECC, and also Diffie-Hellman. Moving on to Grover's algorithm. Grover's algorithm again is a brute force attack, speed up brute force attacking. That is, again, I told you that in brute force attacking, we need to try each password one by one by one. Again, Grover's algorithm, what the Grover's algorithm is doing, it will be able to process, or it will be able to try for like 1,000 passwords at a single time. At a single time, at a single second, by a single second, they can process 1,000 passwords. Now consider that the huge number of the password sets are like 1,000 or 2,000. How many times how many seconds will the machine will take? That is what the major issue that we are dealing with quantum computers. The major issue that we are dealing with quantum computers. Why? Why it is considered as a major issue? Consider that national something that is related with national threat. Now we are sending, for example, we are sending some confidential information from here to, let's say, Russia. We are sending some message from India to Russia. Now it is a national matter. Consider that China is interpreting that particular network and taking that information. Now we are using an encryption method or encryption algorithm to encrypt this. Till date, we are not having the ability to break it. Now consider that once the cryptography or the quantum computers are commercial, we will be able to easily break it. Now it will be, the quantum computers will come in like next 5 years or next 10 years. But the information that we have sent today will again, it will be important even then as well. When we are talking about a company, 5 things in 5 years, the whole structure of company will be changed, and it will not be affecting that company. The information that the company has sent 5 years back, it will not be affecting the company that much. Again, I'm saying an example. Maybe there are information that will be affecting the company even after 5 years as well. But in the national, when we are talking about something that affecting the entire nation, the information that has been shared now will also be relevant even after 5 years. So that is the reason why we are considering like these algorithms or cryptographies, why they are dangerous, or how we need to make sure it is secure. Harvest now, decrypt later. That is what I've said now. Harvest now, collect the information now, and decrypt it later when the quantum computers are available. Now I'm saying that again, quantum computers are easy for us to try as well. There is a website, or there is a company which is called as IBM. They have a website. You can just log into the website. They are providing some amount of qubits for free to use to you. You can do programs into it. You can understand about the working of qubits. You can do programs. You can check whether how the qubits are working, how fast their responses are. That is, again, we are talking about harvest now, decrypt later. That is the threat that we are talking about, and that is why we need to understand about quantum cryptography and how to make sure that the quantum cryptography will make sure that we secure from the quantum, after the post-quantum cryptographic era that we are coming. So how to secure our company data, how to secure our data. Again, we need to understand about this, and we need to make sure that we are updating our knowledge. We are taking necessary steps to make ourselves secure from the post-quantum computer era that is coming up near or soon. What is post-quantum cryptography? Few of the post-quantum cryptography has already been developed by organizations like NIST, and there are other organizations which has developed different cryptographic algorithms, that is post-quantum cryptographic algorithms, to make sure. So these are the algorithm which is crystals Kyber, crystals dilithium, Phoenix, and also Falcon. So these are the few types of algorithm which are capable enough to secure our data even when the quantum computers are available. Few of the algorithms, and it is very hard for our normal computer to process these algorithms. That is the reason why it is not. We are saying that we are not able to secure the information that we share now from the quantum post-quantum era. So again, the post-quantum cryptographies are designed to make sure that the even when the quantum computers are readily available to everyone, they will not be able to process it, or they will not be able to work upon it. So that is why we are the algorithms have developed, which is crystals Kyber, crystals dilithium, and Phoenix, and also Falcon. Again, this can be run in the normal computer or the classic computer that we are using, but again, it is very hard for us to do it. We need a highly specialized, like we need advanced computers to do that. We need high processors to process these algorithms, but we can do it. Moving on to quantum key distribution. Now, key distribution, as I said, when I was discussing about the classic computers, the classic encryption that we are using, I've told that there is something called as Diffie-Hellman key exchange algorithm. Now, in Diffie-Hellman key exchange algorithm, I told that okay, it is very easy. There is a particular algorithm which works to make sure that the information that I've shared from my end to the other end, like the key that I've shared from my end to the other end, will be secure. So there is an algorithm used for it. Now, when it comes to quantum key distribution, now again, when we are talking about quantum, we need to talk about the photons. Photons are the major thing that photons are the most important, we can say the thing that is, or atom that we have, not atom, it is a subatomic particle. So quantum, photons are the particle which we use in quantum encryption or quantum computers. Okay. Now, photons is again what light is. Light is so for multiple photons create light, or photon is equivalent to light. Now we are using photons. So there is, for example, if I am sending the material or the qubits, so qubits can only be sent in photons. Now, when I am sharing qubits to you, when I'm sharing like from my system, I'm sharing qubits to you. Right now, what is happening? We are making it into electron. Electron is sent via waves that we are having. We have radio waves, we have X-ray waves. There are multiple other waves that we are having. Now, when we are talking about photons, it will come under the visible spectrum. So again, we are going back to the 8th standard class that we are going. So light is having a spectrum or the range through which it communicates. The first we have UV, again we have the radio waves, I don't know, gamma waves. Then there are X-rays, radio waves. Then there is something called as visible spectrum in between. That only that particular lights are something that we will be able to see, which is the WIPGR. Then again, we have radio waves, microwaves, different waves structures are there, which is having different frequencies. Now, photons will come under this visible spectrum. We know that it is very hard for us to send a light or to emit a light and to make sure that that light reaches the far away end. We have lasers which will reach kilometers. But consider that when I am sending a message to someone in UK or in US, we are not talking about kilometers here. We are talking about thousands of kilometers. Now, think that how hard it will be to send some light from one point to another without leaving or without uh, distracting or without creating some kind of disturbances to that particular light. The light which is coming, so you might ask like why it is a orangish red color in the morning and the evening, but at the noon it is like white color emitting from the sun. The reason being, when the lights are emitted from sun to earth, because of the disturbances that are falling on the light, it will emit or it will remove all the smaller wavelengths. The colors which are having smaller wavelengths will be emitted from the light, because of the disturbances are more in morning and the evening. The smog, the tiny particles which will scatter the light will be more in the morning. So a white light, again, we are talking about the 8th standard physics, where the white light will, when a white light is passed through a prism, it is a combination of or a spectrum of colors, which is called as WIPGR. The similar thing is happening over here. We are scattering the light. When the light is emitting from the sun and coming to the earth, most of the particles in light is being emitted, but because of the scattering that is happening, because the wavelengths are very small, only the red or the reddish color will be traveling more, because the wavelength is huge, so that it can escape all the kind of disturbances that are available, that are present in the wave. That is the reason why we are using, when a gun or a laser, when a sniper is being used, a laser is kept, or the color of the laser is red. When you look at the reflector, it is red. When you look at anything, that when the visibility is required much more faster, when to attract or to make sure that the visibility is clear, red is the light which is used in order to make sure that the visibility is perfectly, even from the kilometers, even every kilometers away, the visibility of red light will be intact. Again, quantum key distribution, we are talking the mechanics to use it, detect the eavesdropping and also secure key exchange, which is very hard. Now, this is working based on the Heisenberg's uncertainty principle. So quantum key distribution, again, there are algorithms which work. Under quantum key distribution, there are algorithms which work, but the distance that is taken from a particular point to another, will be very less when we consider the traditional electronic system that we're using. Now, Heisenberg's uncertainty principle is one of the principles that we use in quantum key distribution. So Heisenberg is again a physicist. I guess he is from Hungary or something. I don't know. I'm not clear. I'm not sure about the origin of the Heisenberg. So Heisenberg, what he did is he told that, or his principle says that when an electron or when an electron or a photon is traveling, we will not be able to identify the position of that particular photon. We will not be able to measure the position of the photon and the speed of the photon or the velocity of the photon at the same time. That is what Heisenberg's uncertainty principle is. We are uncertain about either of the things. Either it will be the position or it will be the speed. Now then there comes the photon polarization. It works similar to the shades that we use or the cooling glasses that we use. That is, when a light hits on a cooling glass, what the polarization is there are multiple ways. For example, consider that this is how the lights are traveling from the sun to us. Okay, I'm taking a little bit of time over here to draw. Okay, so consider that these are the two different ways in which the light is coming from one point to another. Now, what we do is we'll keep a polarized light over here, polarized filter over here, which is having the slits open only in one direction. So what happens here is only these rays will be passing through this particular polarized filter. These rays will be eliminated, or these rays will be restricted from traveling. These rays will be deflected back. So this is how a polarization works. And it is very hard for me to draw it in a 2D surface. Again, it happens in a 3D environment. So that is polarization. And the similar process will happen in photon polarization, that the photons are sent, the position of the photon or the direction of the photon will be observed, and depending upon the direction, the keys will be created. Consider that the photon is in this particular direction, the key will be marked as 0. Photon in this particular direction will also, the key will mark it as 0. Photon in this particular direction will mark it as 1, and photon in this direction will mark it as 1 as well. Now, photon in a diagonal format, it will also mark it as 0. So this is how the values will be assigned to the polarization or the photons, and then the key will be created. So we are again talking about the key distribution. Again, we are coming back to the classic cryptography where the keys are shared. So encryption works on keys. So a system or a data is locked, and we use keys to unlock this data or this particular data that has been encrypted. So in order to unlock it, the other person should also have the key. So in order to share the key, in quantum key distribution, in quantum cryptography, we use two different methods. One is Heisenberg's uncertainty principle, and also photon polarization. I hope that is clear with you. Sectors that at highest risk. Now, before we talk about the sectors which are at the highest risk, we must talk about the sectors which are being used, or the sectors which use the quantum computers. Which system use quantum computers? Before that, quantum computers are coming in the future. Right now, what it is booming in the internet world is AI. Which sector use AI? Is there any sector which can avoid AI? From my perspective, is no. We cannot avoid, or we cannot stop using AI, or we cannot prevent people from using AI in one sector. Or we cannot say that a single sector will have no use of AI. Every sector in this world, every industries in the world will be using AI, and it will be continue using AI. Similarly, there is not even a single sector in the world which the quantum computers are not helping. Take medical sector. Consider that you need to create, for example, you are from medical industry. Consider that you need to create a medicine. Now, if you want to create a medicine, what you do is we will test it in the rats, we'll test it in pigs, we'll test it in humans. Only then we will release it. Now, instead of this, consider that the system will be checking it with the we'll check it with the different animals, right? And it will be hard for the system to process. Okay, we tested in the one animal, we're testing it the other animal, we are testing it in the another animal. It will take huge time, or it will take a longer period in order to test each animal one by one and to observe their changes. Consider that we have a quantum system or quantum computer. Again, we are talking about qubits, which can be 0 and 1 at the same time. Now, when we are talking about qubits, it can check multiple animals at the same time, so that the answer that we are getting or the results that we are getting will be much more faster. It can be used in, so this is one example, medical example, which is nowhere related to the technology. We are talking about that particular sector. In the sector that we are talking about, so where the quantum computers can be used, it can be used in banking and finances. It can be used defense and aerospace, telecom, healthcare, government, blockchain and cryptocurrency. I'm sorry. These are the areas where we will be using quantum. This is very limited sector. Every sector all around the world will be using quantum computers to make sure that the process, the different technologies, different areas can be understood, can be analyzed much more faster, and the world or the industries will be advancing much more faster when we are using quantum computers. So again, whichever the sector which is using quantum computer, they all are at risk. Consider that the banking information, for example, my card, my credit card or my debit card. I don't want my credit card or debit card to be seen, or the numbers, the CVV number, the dates, the expiry date to be seen by someone else. I don't want to share my information with the other party. This is very sensitive information. So credit card numbers are considered to be very sensitive information. Now consider that even when I'm using an HTTP configuration in my system, the message that I'm transferring is using AES, both the TLS format, which is having both the symmetric encryption and also asymmetric encryption. So TLS is having both asymmetric and symmetric encryption. Now I'm using that system, which is highly secure, and I'm sharing my data with the other person who I don't want that person to see my data, rather than I'm giving them the encrypted format. Now consider that the other person is having a quantum computer and they can decrypt that particular message or do cryptanalysis on that particular message much more faster. And how can I say that my data is secure? My sensitive information has been leaked. That is the reason I told all the sectors which is dealing with some sensitive information or data which should not be shared with anyone else is at risk, and it is relevant to every industry all around the world. I hope I made sense to some of you. Compliance and regulation. So we say that if consider that an organization is following 27001, we say that the particular organization is secure. Why? In 27001, there is a clear statement says that the encryption should be used. And in encryption, which is, they also give the examples such as AES, DES, some public key encryption, TLS should be used to make sure that the system is secure. In PCI DSS, the encryption is talked in the clause number 4, if I'm not wrong, which clearly talk about a encryption system has to be used. The latest encryption system has to be used. So when a quantum computer is coming up, each and every standard, each and every regulations, each and every data security standards that are present right now, which talks about encryption, has to be changed. They has to choose a different type of algorithm, which should be clearly mentioned in their controls or in their requirements, to make sure that the systems or the organization will be secure in secure from all the type of cryptanalysis attack that can be expected when the quantum computers are out or quantum computers are commercially available. Time is to prepare now. Again, when we are talking about time is to prepare now, we are going back to a topic that we have discussed earlier, that is harvest now, decrypt later. Why we need to prepare now? Because the harvesting is happening now. We need to make sure that the system that we are using, the process that we are working on, has to be secured now. If someone is getting our data later, or if someone is getting the data after a few minutes or after a few hours, if they are able to crack the data after 10 years, we will be able to find, or we will be able to they will be able to decrypt it. Future of cybersecurity in quantum world. So how, again, I talked about preparing should be starting now. How to prepare it? There are different post cryptographic methods that are available, which is hybrid cryptography. We are using classical encryption and also post quantum cryptography. You should use zero trust quantum safe encryption. We should use quantum secured network. We should AI and quantum convergence, and also global standard alignments. These are the ways that we can use, or these are the ways that we can secure the internet or secure the data that we are using. By that, my presentation is done. I'm sure that it is taking, yeah, you have 10 more minutes to ask the questions, to go with the questions. Yeah, I can see. Okay, my camera is stuck, and I'm so sorry. I'm so sorry I didn't see the message because I was more into presentation. So I hope, I guess the issue has been solved. My camera is visible. I'm visible to everyone. Everyone. I hope there was no Vishnu. I hope that my my voice was clear to you. I hope that is well. And hey, sir, what points does quantum cryptography brings real threat to today's encryption standard? Yes, today's encryption standards are using AES, DES, reverse ciphers. These are the algorithms that we are using right now. AES, DES, reverse cipher. These are the major algorithms that we are using right now. Because these algorithms are having the encryption systems that are used in these algorithms are easily crackable with the quantum computers. We should make sure that we are securing our systems now itself, because these standards or these algorithms are not is not going to stand in the way of quantum computers. How does second question? I hope the Abhimanyu's question was clear. If you are having any doubt, you can just post it again. How does quantum computer relate to cyber security? Again, Atulya has asked that question. How quantum computing is related to cyber security? I hope that I answered that question, because cyber security, the cryptography is a part of cyber security, and when quantum computers are affecting in quantum computers are affecting in cryptography, or breaking the cryptographic standard, it is again coming to us. I'm a cybersecurity. I'm working in cybersecurity, so it is again coming to us saying that okay, we should be taking care of quantum computers. I hope Adulya's question was also clear. Moving on to Manu Krishnan, how does Shor's algorithm practically break public key encryption? Practically break public key encryption, because we are not finding, or we are not getting in, or we are not doing a man in the middle attack, which is what the Eve does. I mean, my explanation that we are not getting into a network, we are not taking the key. What we are doing is, we should make sure that what the quantum cryptography doing is, quantum cryptography is identifying or taking the data, or the key that we use, or identifying the key. Consider that there are different methods in we use the crypto analysis. That is, finding out the key by getting the data, or collecting the encrypted data. We are finding out the key from the encrypted data. We are collecting, or we are finding out the key from different method that is totally unrelated. Like we don't know what the encryption standard used, and we are finding out the data by guessing it. And there are different other methods as well. So now, how it is practically breaking cryptography. We don't need to have quantum computer to break public key encryption or public key encryption, because it is readily available even now. There are multiple algorithms which are broken, which are used in public key, which are broken even now as well. So we are not doing a man in the middle attack. We are identifying the key. So if we have a key and if we have the data, we can easily decrypt it. So that we are going. That is what I told. We can identify the decryption key. Vishnu, does quantum computing threaten symmetric encryption the same way it threatens asymmetric encryption? Of course it does. That is what again the public key encryption is. Again, yes, the quantum computer will be threatening the symmetric and the asymmetric encryption in the same way. Is quantum is quantum already influencing the attacker behavior today? Yes, quantum again, as I told you, that there is a particular platform which is provided by IBM, which we can use in order to learn, or in order to work with the quantum computers, or the quantum information, or the qubits. Attackers can collect the data, put it in the IBM platform. So it is a cloud platform provided. Anyone can join with their email ID, get into that particular qubit, type in the program, create or do a shorts algorithm over there, and find what the decryption key is, and decrypt the data that you have found out. What again? I hope I answered Ria's question. And going on to Karthika, has been asked that what is quantum supremacy, and does it directly impact cybersecurity today? As I discussed, we are talking about in some situations where the data that, if even if the data is leaked today, which will be having the relevance even after 5 or 10 years, which is what I expect that the quantum computers will be taking to commercially available to all around the world. 5 or 10 years, quantum computers will be available to everyone easily. Even now, it is available via by IBM but in a limited spectrum. But cybersecurity, how it affects the cybersecurity, because as I told, when we are discussing about the national threats, when we are talking about national, the data which can influence a nation, or which is from a country, it will be affecting the uh, people all around. Like, it will be affecting the cybersecurity, because the encryption that we are using now, the quantum computers will only take like 5 seconds, 5 minutes, barely 5 minutes, to break the uh, encryptions that we are using now. Now, consider that you have a data that is with me, which is very private to you, very sensitive to you. I'm using, for example, I'm using I have your credit card data encrypted, and I'm using a quantum computer after 5 years. The expiry date of the card is not completed yet. I'm using the uh, quantum computer after 5 years. I break the encryption. I got to know, okay, this is the card information. I'm buying something from online under your name, under your card. What can be done? So that is why cybersecurity is directly impacted with the quantum computers. I hope I answered the question. If at all
Sir,
there
there
is a
are two more questions that were received during registration.
sure, sure.
First question is from Miss Kessia and Matthew, who is interested
Okay,
in building career in cybersecurity. She
okay,
would like to know what skills, certifications, or practical experience are required to secure an internship with the Kerala Cyber Police. Additionally, before applying, what technologies and tools should she focus on learning?
okay. So the first question, I guess, it is related to what are the skills, certifications that a person needs, or a degree that a person needs. A degree and certifications can only take you till a particular area. What you really need is the skill. You need to understand about the theoretical area of cybersecurity. You need to understand about the practical area of cybersecurity. You should be able to easily manage the systems. Mostly, the skill that you need is networking. So networking is the most important skill when it comes to cybersecurity. So if you are well and good with networking, you can go ahead. And talking about certifications, rather than going for some random certifications, you can focus on uh, the certifications like provided by CompTIA. You can focus on certification provided by OffSec, which is OSCP, CPEND. We have different other offset certifications, which are very advanced. But to build a career, you can always choose a platform like Avanzo Academy. You can always use, because I'm an Avanzo Academy alumni. I learned everything that I know right now from Avanzo, and you can make use of the platforms like Avanzo Academy to improve or to understand about the cybersecurity, understand, build a foundation, learn with the practical as well as the theoretical area. Again, cybersecurity is not just talking about Kali Linux tools and maps or anything else. We need to understand about how the working is. Again, do not fixate on tools. Again, will give you some extra or some information. They will help you to identify some threats. But if you know about how the working of these tools are, or if you know how to do the same activity without tools. So nmap, what it does is they will be scanning the system. They will be scanning the network and identifying the data. They can only do that. Consider that they build a network which is secure from nmap. You will be able to you can do still, if you know how to do the activity without the nmap, you can still do that then as well. So what you need to do is you need to understand some from people who are experienced, so people who have industry experience in cybersecurity. Just talking about some operating system like Kali Parrot is not enough. So a platform like Avanzo, you can make utilize of that to learn about the system and how it works.
The second question was asked by Mr. Delston D'Souza, who would like
Okay.
to know whether cybersecurity will eventually be taken over by artificial intelligence.
uh, e- Cybersecurity will be eventually taken by artificial intelligence. Uh, and then who will be securing artificial intelligence? That will be the question that I will be giving back to you. So in order to make sure that the security in an organization, yeah, security can be some artificial intelligence can help to make sure that the security is managing in, okay, making sure that the data is secure, the data property is secure. We can understand, or we can make help or use the help of artificial intelligence. But again, when we are talking about the cyber security, which area will be taken over completely by AI? Is there any platform that is right now available, or the platform which is has already taken by AI completely? Even the developers will use AI to increase their efficiency. They cannot be replaced by AI. Still, the same happens over here. People can use, or people can make sure that the efficiency of a person can be increased by using AI. It cannot be replaced by AI. AI will always be a helping hand for human, I hope. Right now, the AI that is present that we are using is called as native AI or weak AI. Even when we are moving to general AI and super AI, yes, changes will happen. By I guess by that time we will not be able to. We need not to work, and to make a living, we can hire a robot to do whatever we want. Yes, that's it.
Good evening, sir. Good evening, sir. My name is Vikas
Good evening.
Gopinath.
Hello, hello.
Congratulations, you are a wonderful presentation. And my
Thank
question
you.
to you is, in future, you are talking about quantum computers, and in future, will the quantum computers will be, integrated with the AI? If yes,
Definitely.
what way?
Yes. Please continue, sir,
No,
with your question.
if it is integrated in, but if it is integrated, then in what way?
Okay. In what way? Again, yes, definitely AI will be using quantum computers in future. It is one of the major opening for an AI, or which is major opportunity for us to use AI into quantum computers to make sure that the again, as I told, AI's efficiency that provided by AI can be used, or efficiency that provided by the AI can be increased by using quantum computers. As I told you, if you could remember the qubits that we are using, can process data, multiple data at a single in a single sense, or in a second, or in a single time, a single time use, and multiple data can be analyzed, or multiple data can be processed. The similar structure will happen in AI as well. The AI need to analyze data, AI need to process the information. The similar thing happens over here. It can process huge amount of data in a single go,
Thank you,
and
sir.
it also can make decisions depending upon the data in a single go. Much more efficiency. That's what the quantum computers bring to everyone.
Thank you very much.
And the information that I know about the efficiency of quantum computers, or the effect, the applications of quantum computers in multiple areas, very limited, because it is yet to be released. We don't know how people are going to use the quantum computers in multiple ways, because people we brought AI thinking that people will be using it for a good reason, but again, there are multiple attacks that has been released by using AI. So again, there are multiple other ways that the quantum computers can affecting the organization. We need to look into it once it is released.
Any more questions?
If at all there is any other questions, you can always ask me right now. Yes. Yes, sir. You have any questions? Okay. I guess it was an accident. Is there any questions that can... Is anyone having any questions? Or else...
If you're unable to speak, you can post the questions in the chat box.
Yeah.
I hope there is no more questions.
Yeah.
So thank you so much, sir, for such an insightful and informative session.
Thank you, Aishwarya, for helping me throughout the session, and thank you, Avanzo, for providing such a platform for me to speak about quantum computers and help the people who have joined in the call. If at all, in some way, if I could have helped them, if I have helped them in understanding quantum computers and the future of quantum computing, I'm thankful for Avanzo for providing me such a platform, and thank you everyone for joining the meeting and listening to me. For it's almost 1 hour and 5 minutes. Thank you.
Before we conclude, a quick reminder, certificates will be provided only to participants who have completed the registration form. The link is available in the chat box. I extend my heartfelt thanks to Mr. Vivek and Menon for
Thank you.
sharing his expertise with us. Thank you to all participants for joining and making this session interactive. Please take a moment to fill out the feedback form. Once again, thank you all. Stay connected with Avanzo Cyber Institute for more sessions. Thank you and have a great evening.